Okay, this is my bench test here. This is a 21 plate HHO Brown's gas fuel cell. Pulls about 7 amps when it's warmed up, and it puts out about a liter a minute. It'll displace 1 liter of water in a bottle turned upside down in a pail in 1 minute. As you can see, it puts out a pretty good amount of fuel. There's a plastic holding tank for the liquid up above. About that in line, it's basically the same thing as a washer fluid tank in a car. Just threaded it, put some fittings in there. The acrylic plates on the end of the cell are just for visual. You could put negative metal plates on there, weld fittings on there if you wanted. I just used plastic, and then I went ahead and tapped them and drilled them and tapped them and put plastic fittings. And these are the plates. There'll be drawings included at the end of the video, links to how to get them. There's also drawings for the gaskets. The configuration in the CAD drawing is a little different than that cell you see in the video. I have found that you don't need to turn it on N like I did to get the maximum amount of gas flow come out of it. All you need is basically the liquid line at the bottom and another line at the top for the gas and a little bit of liquid to escape. Causes natural convection as it flows around that loop. More shots of the plates here. You won't have to worry about trying to copy these. There's going to be actual drawings that you'll get at the end of this video. You can go to the links there and download them. Final video here, a couple more slides. That's a positive and negative plate. You see the tab on the far right top, that's where the connection is made. There's a small drawing just to kind of give you an idea here at the end of the slides of drawings to show you how to hook it up in your vehicle. Wherever you're going to hook it up, doesn't have to be a vehicle. I suggest going in before the air cleaner, as you can see there in that picture, using a relay and a kill switch. Okay, so here we are. We've got our acrylic back plate. It's got the bolts around the outside. You see the small hole there in the top and at the bottom of this video shot. Those are for the electrical connections. And then I'm shrink tubing the bolts that hold the plate together. That way, when you slide the bolts through the metal plates, it doesn't short them out. Won't connect to them that way. The large holes in these plates are for the gas to flow through. Basically, water goes in one hole and gets gassed off, and gas and water mixture exit the top hole and flow back up into the tank. Tank becomes pressurized. You take a fitting out of that tank and go into a bubbler or whatever you're going to do. That's your gas supply. I suggest using a safety device. You don't have to if you run it to the air cleaner box like I've just explained, but it's always a good idea to put a secondary bubbler in no matter what you do, just for safety. HHO is highly explosive. So basically you've got a back plate, a gasket, the first positive or negative plate, a gasket, a neutral plate. These are all neutral plates I'm using. If they were positive and negative, they'd cover the holes. And I didn't want that for the sake of the video. I want you to see that you're using a gasket in between each one. You can go up to 4 neutrals in between the positive and negatives, but I've found that 3 is pretty much all you need, and you're going to get a good amount of production off from that. Try to stay under 4 though. You're just wasting your money. You see how it goes. Now, if you kept going there, you'd have multiple plates. I want to make sure that you shrink tube those bolts. And this is kind of a quick show you how it would be laid out, kind of a deal. Those bolts would be shrink tubed. And then you tap those gas lines, and then you can screw your fittings in there and hook your hoses up to your tank. So your cell's producing gas, flowing back into the tank, using the tank as a pressure vessel and to hold the fluid. That way you can remotely locate the cell. You don't have to build this great big box anywhere. You can just mount this thing, as you'll see in the next video. You can put it pretty much anywhere. You just need to make sure the lines are fairly straight, flowing to and from the fuel cell to the liquid container. I labeled my container. I suggest you do that in case you have to take it in for a mechanic. They know that that's hazardous. It's, flammable gas inside of that box. Now you'll see here that those 2 lines are just like on the bench unit. The one on the right goes down to the bottom of the fuel cell, and you can see the bubbles kind of flowing. That's being drawn back just by natural convection. There's no pump involved here. I'm pulling about 5.5 amps right now. It's just starting to warm up. The gas bubbles off and it comes out of the top tube, which is the one on the left, flows back into the tank and pressurizes the tank, and then that fitting on the top left of the tank comes out of there and goes into the intake line. Now I've got this hosed right into the intake line. I've changed that since then. I used a marine fuel filter, which did do a pretty good job of backflash, but I would suggest using a bubbler just for a safety device and to help scrub the gas clean. Don't put that fitting in there like I did in this video. There's just far too many contaminants in the vapor that comes out of the tank, and you'll just gum up everything. See, I mounted the fuel cell down here underneath the fender well. You can put it anywhere. Just make sure you put a drain valve in the line like I did there on the bottom right, so you can drain the thing when you need to change the fluid and clean it. You can use pretty lightweight wire. This is just basically, I've used fine extension cord wire to wire this thing, but you should probably use a heavier wire than I did in this video, just for safety reasons, and make sure you fuse everything. I went ahead and put a defeat switch in, so I'm running electrical power off from the fuel pump circuit on the truck here, but you're going to need to find a circuit that's only on when your engine is running, like I did, and then put a defeat switch in. That way you can turn the cell off if you don't want it to run for some reason. Maybe you're out of fluid, maybe the mixture's wrong. You want to be able to kill the thing without having to pull wires. Put a switch in. Do yourself a favor. Save yourself a lot of grief. As you can see, I turned it off and on here to demonstrate how quickly it recovers. I think I'm up to about 6 amps now. See, again, it's flowing pretty good. Again, liquid in the bottom, gas out the top. I've got that turned on then, but you don't need to do that. If the drawings show a square cell design, that's perfectly good. Okay, I bought this potassium hydroxide online from this online company, and in the absence of being able to find ethylene glycol around here right now, I just use some pool antifreeze to get me through the winter, and it seems to be working okay. But if you have a oil supplier, they can supply you with some ethylene glycol straight. That's what you want to get. You see how much gas this thing puts out. I mean, it really cooks. The point is to keep the amps down, though, so you can keep the steam down. You don't want steam, you don't want moisture as much as possible. Steam defeats the cell. Right now I've got about 6 amps running in this thing. I was saying about the ethylene glycol. If you can get a pure ethylene glycol supply somewhere, that would be best. Get it from a local oil supplier and so forth. They'll be able to help you out. The drawings and everything will be here at the end of the video in just a moment. And if you have any questions, you go ahead and email me, or you can go to my website, terrystech.weebly.com. Thanks for watching.